Methane Stinks? On Earth, Mars, and Beyond, presented by Science at NASA. It's thought that standing near a cow for any period of time will reveal that methane stinks. While methane is actually odorless and colorless, to many researchers, methane is sweet. To exobiologists, it is the aroma of life. To planetary scientists, it is a greenhouse gas and a key ingredient of atmospheres on a variety of worlds. On Mars, it is a scientific bonanza. Hundreds of millions of miles from Earth, NASA's Curiosity rover has caught a whiff of methane on the red planet. On 4 occasions in late 2013 and 2014, the rover sniffed the air and found relatively intense concentrations of methane, a 10-fold increase compared to earlier measurements. This confirmed earlier detections of methane on Mars from ground-based observatories on Earth. Here on Earth, most methane comes from life, mainly from anaerobic microbes called methanogens, such as in the guts of cows, but also from the decay of plant matter and other biological processes in places like wetlands. Does methane on Mars suggest life there too? Mike Muma of the Goddard Space Flight Center in Greenbelt, Maryland says, a leading idea is that methane on Mars is being released from underground reservoirs created by past biology. Leaky natural gas fields on Mars could therefore be a sign of ancient life. Or not. Sometimes methane is a sign of geology rather than biology. On Earth, for instance, volcanoes produce methane. There are no currently active volcanoes on Mars, but scientists are studying the possibilities of methane being released through other geological processes as well. These processes involve reactions of carbon from carbonate rocks or CO2 gas with hydrogen from liquid water. At the right temperatures, these reactions produce methane. The methane Curiosity has been sniffing could be evidence of these reactions. On our planet, methane can come from many sources, including oil and gas systems, coal mining, landfills and wastewater, and microbial metabolism in wetland ecosystems. Charles Miller of NASA's Jet Propulsion Laboratory and his team are using data from NASA's airborne CARVE mission to investigate methane emissions from thawing permafrost and tundra and what these emissions mean for the sensitivity of Arctic ecosystems to warming. Data from CARVE shows increasing methane emissions persisting deeper into the cold season, as climate change keeps subsurface soil temperatures above freezing later into the autumn, as far north as the North Slope of Alaska. This knowledge should help improve the accuracy of global carbon cycle models. At the other end of the solar system, NASA's New Horizons spacecraft has found methane on Pluto. Some mountains on the dwarf planet are dusted with methane snow. Pluto's atmosphere is essentially a 1,000-mile-high bubble of nitrogen spiced with methane and other less abundant gases. On Pluto, methane reacts with UV sunlight to produce a type of extraterrestrial smog. On Saturn's giant moon Titan, methane appears in liquid form, filling lakes and seas. It is also present in Titan's atmosphere, being broken apart by UV rays to create some of the same smog-like particles found on Pluto. Wherever it comes from, methane is an important greenhouse gas, approximately 25 times more potent per molecule than carbon dioxide over a 100-year period. One reason scientists track methane is to quantify methane's contribution to greenhouse warming. Additionally, the breakup of methane can lead to the destruction of ozone. Earth's ozone layer is crucial to protecting life on our planet from harsh solar ultraviolet rays. Mars has an ozone layer too, several of them in fact, even more fragile than Earth's. Methane could pose a threat to ozone on the red planet. Muma says, since the big methane spikes of 2013 and 2014, the gas has subsided but not vanished. Curiosity is currently sensing methane at very low, yet still variable levels. Muma is looking forward to measurements from a new spacecraft that could clarify what's going on. Europe's Trace Gas Orbiter was launched in March and will orbit Mars in October of 2016. The spacecraft will be able to monitor methane as well as other trace gases Curiosity is detecting. Within a year of its arrival, the Trace Gas Orbiter will attempt to map the entire planet and identify areas of methane release. Muma says, once we know where the gas is coming from, we could target future missions to investigate the methane at its source. Stay tuned for more clues from science.nasa.gov.